Okay, it seems it's time. So let's start with a little warm-up for everyone gathered here. So who of you know of hexagonal architecture, heard of it? Who of you know it well? Who of you use it in their projects? Okay, that's interesting. Actually, I wanted to go now to back again to the question, like, out of people who use it, do you know it well? But you did it for me, you did the joke for me, so let's skip it. Yeah, either way, let's start with a little reminder. Of course, this is not my work, this is Herberto Graca's blog. So hexagonal architecture is hexagonal architecture, of course, right? Everyone heard of it, it's clear what it is. We have this domain in a very center of it. It is strongly isolated from the outside world and all the impurities of it. But it still needs to somehow cooperate with the outside world, right? So we need to be used by the outside world and use it as well. And it does it through the ports. So the ports are basically like what the domain imagines the outside world could want from it, or what it imagines how it can use the outside world. But imagination itself is not enough, obviously. Someone needs to do the heavy lifting, and this is where adapters come in, right? So adapters do all this heavy lifting, they map between the contexts, and we have both ports and adapters. We can split them into primary and secondary, or driving and driven. So on the left, we have the primary or driving ports and adapters, and on the adapter side, we can have things like REST API or HTTP API, or we can have event listeners, or maybe the part of task scheduler that actually executes the tasks after they have been scheduled and when it's time. In this diagram, we even have CLI, but I don't know how many of you use CLI, so maybe let's skip it. And on the secondary, on the right side of the diagram, we have the secondary side-driven adapters, and there we had the REST API on the left, so here we can have REST or HTTP clients to other microservices. We had event listeners, so maybe we have event publishers. We've had CLI, so maybe we also can use other processes within the system, or maybe the disk. Of course, we also have the database, right? So everyone has the database, so this is where it lies. And this basically sums up the presentation on the hexagonal architecture. All we need to do is a quick demo, hello world application, and we can close it, we can go celebrate already, and spread the world and make the world a better place with our hexagonal architecture. But is that true? Is it actually this wealth of knowledge that we've just gone through very quickly, is it actually enough to understand what's going on? I would say that this diagram or this approach is very behavioristic in nature. So it explains how things are structured, how they look like, how they work, but not necessarily why. What are the motivations behind doing things a certain way? And this is what I would like to focus on today. My name is Krzysztof Przygudzki. I'm a software developer. I work for Hyper-Exponential, and I have before worked for companies like Hazelcast, Toke. I've been a team leader for Allegro Smart as well. And the most important slide of all, so in summary, I encourage and welcome everyone to try this at home and at work, but remember, you do it at your own, not peril, but risk. So now that I have built some rapport with you and some trust and authority, we can move forward with the presentation. So we said the hexagonal architecture, we have this domain in the center, and we said that this is strongly independent and isolated from the outside world. But we might ask, what does it actually mean, right? And instead of looking for an encyclopedical definition, I'd rather focus on some things that are maybe everyone here possibly can relate. Everyone who writes code. I know not all of us write code, but if you do, you probably know what I'm talking about. So on the very, very lowest of levels, what we do every day basically in our work is we break code down into functions. We extract functions, and we do that. It's like a very simple form of isolating some piece of code, right? So we do that mainly because with functions we can decompose a bigger, more complex problem into multiple, but smaller and easier to solve ones, right? We also, through introducing functions, we can promote code reuse instead of duplicating this code. And later, when we actually want to change some behaviors, some logic, hopefully we only change in one place and not all this duplicated mess, right? So we collocate the changes to increase the cohesion, reduce chance of errors or mistakes. On a step up in abstraction levels, we also extract classes. And when talking about classes, we are in the JVM conference. Java has a very strong OOP paradigm, so we can focus on objects. Hard to not to mention those. Objects are very special kind of classes because they collocate state and logic in one place, and these things change together often. Like if one state changes, if we change the representation of our state, internal representation of our state in an object, we probably also want to change the logic that's based on this state, right? So again, we collocate the changes that are related to these things, but at the same time, objects encapsulate their state. So as much as they might allow for some clients to access the state, they do not allow modifying it. So if you want to modify the state, if you want to mutate some object or create a new object with mutated state, what you do is you need to do it through behaviors, right? So an object exposes a set of behaviors which form an API. And through this API, we can decouple the consuming code from the object itself, right? So if we change the internal representation of the state of the object, we can change it later as long as it doesn't impact it doesn't involve changes in the API. We can guarantee that this change is located only in the object and doesn't involve changes in the consuming code. And a level of abstraction up. What we do is we extract packages, right, in our code. So we break our code down into packages, and there are basically two approaches to this. I mean, there are multiple, but I guess we can categorize them as two. So we either break it down or split horizontally or vertically. And the vertical split, what it means is basically we want to split based on the domain context, or like the business context, right? So in our application, we might have some classes that related to products and invoices. So all the classes that related to products, we just throw in one package, we call it products. All the other classes that are related to the invoices, we throw it in a package, call it invoices, etc. And this is a useful way of splitting because, first of all, it introduces some logical order and some structure to our project. It also eases the navigation a little bit, right? So instead of having this one big package to search through, we can now go into more narrower package and look for the code that we want to understand or change. Also, an important factor, in my opinion at least, is that it also allows or helps us collocate changes, because it's easy to imagine a change that will only affect products or only affect invoices and not necessarily affect any other vertical slices of the code base. And so the opposite to that is the horizontal split, right? So we can divide our application into horizontal parts. And again, this doesn't have any like meaning to itself, not literally. It means metaphorically breaking down the application based on the technical context. So here we have, for example, some classes that are responsible for exposing a RESTful API. We throw it in one package, call it, let's say, presentation. We have some classes responsible for integration with the database. We throw it in another package. We call it we call it persistence, for example. And again, this is useful because it introduces some order, some structure to our applications. It makes it easier to find stuff because, again, we have smaller boxes to look through, not necessarily this one big box. And stemming from that, we have the layered architecture. And this is the classic outdated layer architecture. But let's start with the general concept, what layered architecture introduces on top of this like horizontal split. And what it introduces is, first of all, it's no longer just like abstract, horizontal, whatever. Now we are actually talking about layers because we have introduced an axis, vertical axis, and we have placed those horizontal bits along this axis. So now we can say that one bit, one package, one layer is on top of the other or under under another. And also, layered architecture introduces one important principle. So it says that that layers can only depend or use or know the details of the layers beneath, but it can never they can never know or depend on the layers that are above it. So what this means, we can also call it like a consistent direction of dependency, which goes top to bottom. And this is the classic, and I said outdated, and I mean it, obviously layered architecture, where we have from top to bottom, we have presentation layer, business logic layer. This is sometimes split into application and domain layers, but it's kind of non-consequential to at this point, so let's skip it. And at the very bottom, we have the persistence layer. And again, this is useful because we can imagine, for example, that we want to expose a new API, like V2 API, whatever, V5, or maybe we're using SOAP, now we want to use REST, or maybe GraphQL, whatever. So this is, we can say that this is a change that is only really impacting the presentation layer, right? So we can actually guarantee this way that this will only impact the presentation layer. We can limit the scope of possible changes, right? So as long as we don't actually need any changes in the business logic layer, we do not actually need to touch it, right? We can guarantee that we are isolating these changes are isolated to the or limited to the presentation layer only. But this approach has a very significant drawback, and it's this persistence layer at the very bottom, because it means that now our applications have become heavily database-centric. And what does it mean? I mean, the persistence layer is at the bottom, so everything depends on the persistence layer. And now, also, I mean, now maybe it's, again, it's outdated, outmoded, so it's not maybe the state of today. Maybe at some projects it is. But years ago, people were thinking, you know, when we are thinking of changes or modeling or whatever, we start with modeling the database. How do we structure data in the database? And then we go to the top, right, from there. So we start with the database, then we start with some persistence model, and only then we start with like the business logic and REST APIs, right? And also the other issue is that many of the projects that I've seen, the way they work is we have this persistence layer, right? You have some persistence model. We're using, I don't know, JPA, for example. So we have the JPA model, and we are kind of inheriting this model in the business or like domain layer, business logic layer from the persistence layer. So why go to do the extra effort of implementing additional domain model if we have one already, right? But then the problem becomes that we need to add some business logic to this model, right? And well, it would be great to have to make our entities like proper objects, add some behavior to them, but it's kind of doesn't really make sense to, you know, business logic, as the name implies, should go in the business logic layer, not in the persistence layer. So what we end up doing is we spread or smear to an extent all this business logic around these entities in some services, and this is what's is usually referred to as an anemic domain model, right? So we have all this logic in the services, and we have objects that are basically just data, sorry, we have entities that are basically just data structures, not very useful on their own. And the biggest issue of all is that, so we have, you know, we have this thinking that starts with the database, and we have this anemic domain model, but the clue of this thing is that the business logic is actually the one that's kind of most important. It depends on the application, obviously. From one project to another, it will change. We have, you know, all this like a lot of technological amazing stuff, right? We have events, we have async stuff, we have distributed stuff, we have concurrent stuff, we have cloud native, all these things, big data, AI, and but all of these are really just enablers. I mean, they are crucial. They are necessary. Without them, maybe we couldn't do things we do at a scale that we do. But they are not what is making us money, right? And at the end of the day, they are enablers for this business logic. They are enablers for this just bunch of weird ifs that no one really understands why it works like that. But some project owner or whatever product owner said, oh, it's the way it works, or the domain expert said it, and now our application works this way, right? So and the issue is that in this way, with this model, we cannot actually guarantee that these changes that are done to the database, for example, will not will not impact the business logic layer. And this is the issue. This is the database-centric architecture, and this is the old way of doing layered architecture. But we have actually advanced since these days, and we have found a solution to that. But so what would we like really to do about it? So the issue we have is the persistence layer is at the very bottom, and we have all the applications depending on it. We'd like to get rid of it. I mean, not get rid of it because we need it all the time, but we need to move it to the top, like, or at least above the business logic layer. And where's the will? There's a way, and this is precisely what we do using the dependency inversion principle. And this is not like straightly, the dependency inversion principle is not really bad. It's kind of like a side effect stemming from it. But the side effect is that we can actually invert dependency between some components without inverting the direction of control. And this is precisely what we're looking for. So in practice, how it looks is that our business logic layer now exposes some interfaces which describe use cases. So basically, again, how our domain, our business layer imagines the outside world to be and how it imagines it can use it. And then someone has to do the heavy lifting, right? And that's what the persistence layers is for. And it's at the top, so it can depend on the business logic layer. It can take all these interfaces and provide implementation for it. And it actually turns out that this is not limited to the database, right? We have in our modern applications, microservices, we have plenty of use cases where this would be very useful, right? So we have, for example, the HTTP clients or REST clients to other microservices. We can use it exactly the same way, right? Or event publishers, we can use it the same way. So our business logic needs to use something external, but it doesn't want to know the details of it. And so this is what we do. And we throw all this stuff in the persistence layer, but it's not really persistence. So we can generalize the name. We can call it, let's call it infrastructure layer. And that's great. So this is the modern layered architecture. So from the top, we have the infrastructure layer, we have the presentation layer, and we have the business logic layer on the very bottom, which is isolated from this, all this like outer world, outside world, no nonsense. It's strong and independent. And now, if someone is paying close attention, they might be asking this sort of a question. So why do we really need hexagonal architecture? I mean, if hexagonal architecture, what it does, it promises it will isolate our domain from the outside world. We have actually done it here, right, with layered architecture. So why do we need a hexagonal architecture? So let's look into that. And let's again, instead of looking for encyclopedic definitions, let's just focus on like small things that everyone could relate to. So first of all, layered architecture, the modern one, after we made this trick of flipping the stuff and throwing the infrastructure layer to the top, it has one drawback, namely, as much as it preserves the direction of dependency, that we have this principle, right? So we have the dependency top-down, from the top to the bottom, but now we have the direction of control is actually inconsistent, right? It's not straight. So what does it mean in practice? It means that if we have a request coming to our application, it comes to the controller. The controller is located in the presentation layer here, right? And now then it calls some service. Service is located in the business logic layer, and then we need to maybe retrieve some entity from the database. So the business logic layer will call the repository, but the repository is actually, the implementation of the repository is in the infrastructure layer, right? So as the red arrow shows here, the direction of control is not consistent, right? It's not easy to understand here from this diagram. And what hexagonal architecture, how does it solve this problem? It solves it in a very simple way. So the drawback of the layered architecture is that it only has one dimension. It only has top and bottom, right? And with hexagonal architecture, we actually introduce second dimension. So it sounds really trivial, but it's what it does. So we have now the same example. We have the request coming into our application. It lands first in this primary adapter here, some REST adapter. It goes through the port to the domain. Now we need to the service, which is the port. It goes through the domain. We need to retrieve the entity from the database, so we call the secondary port to retrieve from the database. And the implementation of this port is in the adapter, or the secondary adapter on the right. So as we can see, we have the this one diagram can fit both the direction of dependency, which is outside in, and it can also fit the direction of control, which is left to right. Yeah, so this is a problem that you didn't really know you have, but now we have solved it for you with hexagonal architecture. So yay, 1-0 for hexagonal architecture. So let's take another example. So we have the project structure, right? On the left, you have like the typical layered architecture structure of a project. So you have this application, domain, infrastructure, presentation packages. Everyone knows it by heart, I'm sure. And on the right, what we have is the equivalent project, but it's structured a bit differently because it's kind of structured based on hexagonal architecture and ports and adapters approach. And let's just quickly think about how the packages on the left map to the packages on the right, right? So how would you do that mapping here? So for application, for domain, this is really, really trivial because it just translates one-to-one to application in domain in the project on the right. But for infrastructure and presentation packages, it's actually not that clear-cut. It's not one-to-one. Why? Because infrastructure, what do we have in the infrastructure? We mentioned, for example, implementations of the repositories, right? So database integration. So repositories are part of the secondary adapters. That's also what we mentioned. So we maybe can fit it into like adapters GPA package. Kind of makes sense, right? The issue with infrastructure package is its name. And the issue with its name is that it is very, very generic and general, and we can easily fit anything into it, right? So how about some configuration, for example? Should it also live in infrastructure or not? Well, perhaps if it's related to database, for example, how do we store dates in our database? In what format do we store time zones in the database? Then perhaps it should live in this adapters JPA, this configuration, right? But if we're configuring Spring or some external libraries that are not really part of these layers of the application, then it shouldn't really live in the infrastructure package, right? We have actually avoided this issue here because we have this config package here, so that's very, very useful. And now for the presentation package, it actually has the opposite issue. So it's not instead of being too generic to open to interpretation, this is now a bit too narrow and too constraining. And what do I mean by that? So in presentation layer, what do we have? We have REST API, for example, right? So this clearly goes to like adapters REST. It's a primary adapter. Everything is easy. Life is good. But where is the issue? The issue is what do we do with components like, for example, event listeners or task schedulers, at least the part of the task scheduler that actually executes the task, not schedules it. So where should these components live, right? In which layer and etc. So should it be infrastructure layer? Should it be presentation layer? Should it be business logic layer? Well, clearly not business logic layer. Well, not the domain layer, but maybe application layer. It's kind of unclear. But in the world of hexagonal architecture, it's actually pretty clear-cut, because if we think about it, to put any component, any class in here, we have just the answer to questions. The first question, is it part of the domain? So we have, I don't know, SQS listener, for example. No, it's not part of the domain. I don't want it. It's like an external dirty stuff. I don't want it in my domain. So it's an adapter. So then the question is it primary adapter or secondary adapter? So in this case, the SQS listener is something, or the task scheduler, there are things that actually consume our domain. So they depend on our domain and they consume it rather than being consumed by it, right? So this means that clearly they are primary adapters and should live the left of this diagram, but also the primary adapters map to the presentation layer in the layered architecture. So clearly, again, we have this insight that in layered architecture they should also live in presentation layer. So again, another problem we didn't know we have, but now it is solved. Great job. 2-0 for hexagonal architecture. So now the big problem, the big question: what happens if our layers grow too large, right? So we discussed earlier, we can, when we have too many classes, we can split either vertically or horizontally. So let's start with horizontal, because it with layered architecture, it seems intuitive. So let's look at it. So first thing that comes to mind is let's just add more layers, right? What's the problem with that? So there's not a lot of a problem, really. The issue is that we very quickly run into the issue of how to fit more layers in there while still preserving this approach that we have this direction of dependency from top to bottom. And maybe there is an optimal number of layers in our projects, most of the projects, because it depends on the project, obviously. In some projects, you can fit much more, but in most of the projects, maybe the number 3 or number 4 is actually the optimum. It doesn't really make sense to go any deeper. And so what else can we do? Instead of adding more layers, we can introduce, divide internally our layers. So we have the layers, and we can take a layer, take all its classes, and just internally within the layer, break it down into some horizontal packages, horizontal parts. So how would that look in practice? We can introduce packages. We can say this package. So again, horizontal split is based on technical context, right? So what can we do? We can have a separate package for services, separate package for DTOs, separate package for exceptions, separate package for for example, in the presentation layer, we can have a separate package for the controllers, separate package for responses, separate package for requests. Is that useful? To an extent, perhaps, because if I'm looking for a service, I know that I just need to look in the service package, right? So it's clear cut this way. But when it comes to actually changing and working with this code, understanding it, navigating through it, it might not be that easy, and especially with changing. If we said before that a good way to split our application gives us this collocation of changes, right? So that when I change one class in a package, for example, let's say there are 5 classes, I change 2 of them, maybe and all my changes are just within this one package, then maybe it gives me motivation to go look through the other 3 classes and see whether maybe there's other stuff that I have missed somehow. And here we have actually the opposite, quite the opposite, because here it's really easy to imagine a situation where any of our changes really just touch one class in each of the packages. So basically our changes are greatly distributed across all the packages. So again, it's not really useful from that sense, right? So our changes are not collocated, rather distributed across the whole code base. So what's the alternative? We mentioned vertical division. So let's look at it. So what we can say is our application is divided into those layers, and we can split those layers internally into some vertical slices. So how could that look like? This is actually a bit idealized diagram here, because as you can see, there's equal number of parts or packages in each of the layers, and this is usually not what happens, because the layers that grow the fastest are the domain layer, the application layer, and we want to split them first, and usually we'll just have one presentation layer, one infrastructure layer, because there's not so many stuff in there. We're not really bothered about it. But let's go with this idealized example where we have the same number in each layer. So we can kind of say that we have now introduced, we have the layers, but across the layers we have introduced this contexts. Is that useful? Yes, I think that in a sense it is useful. Again, if I'm looking for products, I go to the products package in any of the layers. If I'm looking for invoices, I go to the invoices. It's kinda obvious how to navigate it. It also kinda collocates the changes because they will not be collected in a single package maybe, but maybe within each of the layers there will be only one package that we change. So it's kinda maybe a bit better. But does it answer another question, question of coupling? Because it's easy to imagine a scenario here where, let's say I have an invoice, I need to issue an invoice, I need some details from the product. So what do? Into my product service, I inject the product, into my invoice service, I inject the product repository, I just query for the product I'm interested in, I take it, I take the attributes that I'm interested in, and I use it to build, to create an invoice that I need, right? So that's simple. And actually, why go through all this hassle if I have this like JPA model or whatever? I can make product relation relative of my entity, of my invoice entity, right? So invoice can just have the list of products, whatever structure we use there, it can just use it directly, right? So through my invoice repository, I can retrieve the invoice with all these products already there. So I don't really have to do too much work, right? No additional work with injecting beans or whatever. But if you don't see the issue with that yet, let's go a step further and imagine another scenario. So in this scenario, we have product owner says, oh, you can modify the products, but only until we sell it. And once we sold the product, we can't modify it anymore. You have to like make a copy of it, like new version. Then you can modify the new version, but this old version needs to stay forever the same. We can't change it. So okay, we have the product service. We have some method for changing the product. What do? We just need to inject the invoice repository, retrieve the invoice, or rather look for any invoice that uses our product. And if there is any, we disallow changing. We suggest creating the new copy, new version, whatever. Yeah, that's cool, right? And as you can see, maybe there are like some arrows are crossing each other. One is going left to right, the other is going right to left. But I mean, everything is super clear here, right? Because we have this like direction of dependency from top to bottom, and we have stuck to it. We don't really do anything weird, right? So it should be all good. But the issue is that we have this, this contexts, domain contexts or business contexts, but we do not really enforce their boundaries this way, right? So we allow going in either any direction, and this just introduces like a spaghetti at the end of the day. So what can we do alternatively? So we said that we analyzed splitting vertically or splitting horizontally, but we don't really like any of these solutions. So what can we do? What else can we do? So the problem is that we kind of started with this, supposition that we first break down our application into layers, but the solution is actually to take a step back and first think about how we should divide it. And maybe the good thing to do is actually start with vertical split first, and maybe do the horizontal split later if we need that. So we first divide our whole application into modules, and then if we want to, we can introduce layers, whatever other architecture within those modules. It doesn't really have to be the same across these modules. And that's great, but again, does it help us with coupling? Does it help us protect or enforce these boundaries between context? Not just yet, but let's say introduce some rules to here. So first, let's say that our modules, they have APIs. So if dear invoice service, if you want some information about the product, you cannot just go to the product repository and retrieve some product. What you need to do is you need to talk to the API of the products, and API of the products would be probably like some service or something like that. So go to product service and talk to it. So now we have introduced APIs, right? So if now the product internal representation of the product module changes, the invoice module doesn't really have any direct dependencies, or it shouldn't inflict too many changes within the invoice product now. But we can go a step further and say that our modules also should have SPIs. So why should invoice service know about the products in general and like the specific products that are there within a module? Maybe today I have one module, maybe tomorrow I'll have two modules or something. So instead of having this direct dependency, let my invoice service express some, it can imagine how it wants to use these products, and it can expose an interface with some use cases, and then someone else will do the heavy lifting of implementing that interface and actually having the dependency on the product service. So we can imagine that if we have a number of classes, for example, in the invoice module that are consuming these products, if things change there, it will impact all of these services within the invoice module. But this way, having this SPI, we actually isolate all these changes to just one place, right? So if we want to maybe split product module into two separate modules, all these changes that are really needed will be collocated in one class in this implementation of some product client or something like this. And this is how we can solve this issue of coupling between this domain context, basically, and that's the way to go. So modular monolith, basically. This is what we land. And if you haven't caught that yet, it translates perfectly into hexagonal modules, so or hexagonal architecture. So we have this the invoice service on the left. It uses some product client. This product client is implemented by an adapter which consumes the product service, so the port of the product module, and then we go forth into the product hexagon or product module to do further work. And yeah, and the point here is that what hexagonal architecture really helps us with, as opposed to layered architecture, it helps us to manage this growth and identify early chances for splitting into smaller parts, into extracting, or purifying, extracting smaller parts, smaller components, smaller modules, instead of letting them grow indefinitely into spaghetti monoliths. Yeah, so let's take a closer look at the adapters. So what happens at the very boundaries of our hexagons. And so we have the adapters. The name adapter is not really coincidental. It's just it uses the adapter design pattern. So ports and adapters is just the adapter word there follows the adapter design pattern. And what is adapter design pattern basically? So it solves a very simple issue. We have two components. Here they're called active component and passive component. And now active component needs something from the passive component, but we don't want dependencies between them, right? So neither one of those components want to know specifics of the other. So let's take an example here. So our application, we often say something like, our application, it's so great and pure, we don't want it, muddied by Spring. We don't want it to know about specifics of Spring, that we're using Spring. But then we make a call to the to Pivotal guys and ask them, could Spring have dependency in our application? They say, no, we don't want that either. So we need to find some other solution to that. And the solution is, as it often is in programming, we just introduce a third party here, a third party that has dependency on both of these components, and it allows the control to flow through it from one side to the other. So the active component exposes an interface where it describes some use cases, how it imagines it can use the other component. Then we have the adapter that implements this interface and implements those use cases by consuming the passive component. And more specifically, in terms of hexagonal architecture, we said that we have driven or primary adapters, and we have secondary adapters. So primary adapters, the ones on the left. So we have some external component that needs to, or we want it to use our domain or our module. It obviously doesn't know about it. So what we do, but it exposes some use cases, right? Some interface that can be implemented by the adapter, and then this adapter can consume our driving port, which is usually some service, or maybe we have multiple services, we can hide them behind the facade. And one important maybe thing to note here is that sometimes we are tempted to maybe use some like interfaces for the services so the entry points of our application, but it doesn't really make all that much sense, because in this example, the driving port, the service here, it's only consumed by the driving adapter. So we don't really, I mean, if we need to change the driving port, change its implementation, we'll just, we are owners of both of these pieces of code, so we can easily change both at once. It doesn't really, it's not too bothersome. And also, if we want to hide some implementation details, maybe some fields, etc., of this service, we can just use private. So again, unless we actually need to, swap some implementations like in place, so have one implementation sometimes and sometimes another, it doesn't really make sense to introduce interfaces here. And this is, in general, this is what I just told you about the architecture here. It's great theoretically, because in practice it doesn't really happen like that. So it's not very useful. The issue with that is, especially if you're using Spring or similar products like that, Spring doesn't really like you to do too much. and the way around it is with all these annotations. So Spring uses declarative programming, right? So instead of having an interface and needing to implement some use cases there, if we want to expose a controller, or a REST controller in this case, what we do is just we create a class and add an annotation, right? And if we want to have like an endpoint in that controller, we create a method and add annotation. So basically, if something doesn't work the way it's supposed to, just sprinkle more annotations and it should work. That's the silver bullet there. But in fairness, in some sense, it still does work like that. It's just it's not us that are doing this work. Because what happens is at runtime, Spring will find all these classes, all these annotations, all these methods, and it will implement some interface internally. It's just we don't have to do this work, right? But it still kinda happens this way, but it's just not really visible to us. The important part here is the context mapping at the very bottom. I'll get to it in a moment. Okay, so we have primary adapters, we have secondary adapters, so the driven adapters on the other side of our hexagon. So in this case, it's our domain that needs something from the outside world, and again, it exposes some interface, some use cases. Repository is a great example here, and we have the driven adapter that implements these use cases by consuming an external component, and it can be a concrete class or an interface. And in this example, code example, this is Spring Data GPA. So obviously we have an interface. And yeah, here the Spring Data GPA product repository is the driven adapter. It implements the product repository, which is the driven port. We have this external component of internal product repository. And it might, for some of you, it might get kind of weird at this point. And the thing that might be kind of fishy here is that given that product repository itself is an interface, and also what we have from Spring, what we get from Spring, the CRUD repository is also an interface, it's kind of tempting to make product repository extend CRUD repository, and we should be golden, right? We can just extend it. And there are some issues with that. I'll not go into too far into it, but the biggest one is again about the context mapping. So with CRUD repository, what we need to do basically is we need to, it's usually how we work with it, is that we store the entities, but these are persistence layer entities, right? So they are part of this persistence model. But what we want from our domain repositories is to work with our domain model, right? Entities from our domain model. And this context mapping is now what is really important, the important part here. So just in this case, it's just mapping from one entity to another and maybe doing some a bit more fancy stuff with queries or whatever. And we have this internal product repository at the very bottom, which is just like an implementation. It's an interface that extends the CRUD repository, is obviously implemented by Spring at runtime. And we have this entity class at the very bottom, which allows us to have this separate model, separate persistence model. And this allows us to keep our domain model classes clean, but also to have, to have a different model for the domain and for a database. So if we want to introduce some changes really quickly, we can do that by, we are not limited. We do not have to do changes in our code in our database at the same time. Thanks to this, these two are decoupled, so we can do it at different times, right? So we can change our domain model now, and the database can follow whenever is useful, or the other way around, obviously. Yeah, and as a bonus, we have this like modular adapter. So if we have two modules, two hexagons, we have this adapter that implements the driven port from one module, and then it consumes the driving port from another. Here, the pro tip is that you don't need two adapters, you just need one. That's going to bridge between those. And I mentioned dependency inversion principle, and this is precisely like to just close about adapters. Dependency inversion principle, we said that it kind of allows us to invert the dependency without changing the direction of control. But also, I mentioned that this is just like a trick that we can use it for. It's not what it stands for. Actually, the dependency inversion principle, the principle itself, stands for, it's a principle that tells us that communication between different components should always be on the highest possible level of abstraction that is like mutual to both of those. So the component with that has like a higher level of abstraction should never depend on the specifics, the low-level stuff in the other component. And what it gives us, if we stick to it, if we do it well, what it gives us is it gives us adapter interchangeability. So we can take our adapter and we can swap it in place for another one. So this, obviously, the haters of Hexagon will now say, "Oh, have you ever seen someone replace SQL database with NoSQL database?" I haven't, but yeah, let's not go into it. It can be it can be still useful if you're not doing these huge changes, right? It still can be useful if you, just for tests, for example, if you have a hexagon, you have some boundaries of the hexagon, these boundaries can serve you very well to define boundaries for your unit tests. So you can build your hexagon, like your module, just by hand. It's not too much work to do. And then you can use the boundaries, the ports, as places where either you as points of ingress for your module, or as points of egress, where you either use mocks or use fakes, etc. And this way you can easily unit test your module, not just one class, but a bigger piece. But also to have like a more interesting example, maybe. We mentioned the modular monoliths. And modular monoliths are stepping stone to microservices. So maybe time comes when we want to actually lift one of those modules outside to another application. And this adapter interchangeability is precisely what we can use then, because we can easily replace we have an adapter. Today we have an adapter that just is between those modules within the same application. But tomorrow, when we lift it out, we just need to replace it with two adapters communicating over REST, so primary and secondary adapters, and we should be good, right? So we can very easily do this sort of thing when we lift one module out of the application. And obviously, hexagons have their limits as well. It's not like you can't always do it clean. As much as some of us would like to, you can't always do it. And one of the clear-cut examples of that are transactions. How do we implement transactions in our applications, right? So on one hand, they are like related to the database. So maybe they're not part of our domain for sure. So let's put them in the secondary adapter, the one related to the database. That's great as long as all we need from the database is just to store some aggregate or retrieve some aggregate. Then these transactions are useful because they allow us to modify multiple entities at the same time or whatever. And that's great. But what if we want more? Like what if we need to extend this transaction to the whole, like a bigger part of the process, right? Not just interaction with the database. Not two separate transactions, but rather one bigger one. And we can do that And how do we do that? Maybe we should put it in the primary adapter, right? So like in the REST API. But then if I put it in the REST API, and the annotation, for example, transactional annotation, right? If I put it in my REST API, I need to, when I expose another API, I need to remember to also use it, right? Or if I expose it differently to an event listener, for example, I need to remember to reuse it, otherwise things will go sour. And then maybe after some back and forth, we come to a conclusion that actually, if transactions are integral part of the logic for our application, then maybe we should just model it in the application layer. And maybe this is just something that we have to do. And we need to remember that at the end of the day, our code base is just, our project is just an implementation of use cases. So as much as it would be great to start with the domain, start by modeling, do all this clear and super stuff, at the end of the day, it's not, well, I mean, we're not working in Haskell, I assume, so we need to use it this way. And to really like close up here, the last question would be, what is architecture really? So is it all the packages, all the project structure, design patterns? I don't think so. I think it's something more abstract. It's like the mental model that we have in our minds is like an ideal that we have in our minds about how our project should be structured, how it works, how it should develop in the future. However, all this stuff like package structure, project structure, design patterns, they help us because they are the ways for us to express our thoughts, this ideal that we have. And in this, the code being this like, imperfect reflection of this ideal that we have in our mind, we can use all these tools to express that in our code, because code is read by many people and everyone will have a different idea about how it's structured, how it works. And this tools for expression basically allows us to make everyone think about it the same way. This is what we strive to do. And that's it. Thank you very much. Do we have some questions? Do we have the time for questions? Okay, so very quickly, how you would overcome issue with lazy loading during context mapping in repository? In presented example, to map entity to domain, you need to load all relations. I think the question really is like how many relations you need, and because technically speaking, you should you should take from the repository exactly what you need and nothing else, right? So lazy loading is just a trick to limit the scope of the repository or the number of methods or whatever. So I would say that you just need to map whatever you need, and maybe you should think about whether do you need all this other stuff. And if you do need it, but maybe not always, maybe sometimes, maybe instead of having a relation, like a JPA relation or database relation, maybe what you need is just the ID of this thing that you need to retrieve, and maybe you need just to perform another database call to retrieve it. It might not be the most performant way to go about it, but it's kind of clean because it allows us to to cut this into smaller pieces, into aggregates that we operate on as one. I hope this answers the question. Is it worth to keep the domain model separate from the database model if the context mapping is just copying all the fields one-to-one? I mean, it depends. It's always this kind of struggle, like do we do stuff clean up front, or should we start with something simple, and then when it gets more complicated, we'll make it cleaner, right? That's always the question. I think in many instances, it's actually doing this well and cleanly in the first place doesn't introduce that much overhead into our work, but it allows us to to be to go the right direction, like choose the right direction up front instead of waiting until later, because it's for example, if you have a bunch of ifs and then someone refactors to switch statement or whatever, or some strategy pattern, whatever. It usually doesn't happen when it's like 13 ifs and someone adds the 14th. It's usually either very early or very late. So it's either someone designs it up front where it's maybe 2 ifs or 2 or 3 ifs, like if else branches, and not when it's 13 and someone adds 14th. It's usually not the point, because usually we're just trying to solve something fast. There's no time to do it more of it. More questions, or should we wrap up? Okay, I'll continue. Okay, so for the sake of convenient usage, add JPA annotations to the main models, yes or no? So again, I think it boils down to something that is, it's not just about the annotations, right? It's whether we want to conflate our models into one, or whether we want to have separate ones. Do we want this to always be one-to-one, or do we expect it to diverge, right? Do we want maybe to have because we have object model in our domain model, and this is what we want to do. We don't want bidirectional dependencies there, or like relations there. I think there are like a lot of different things that don't really fit well into the object model, but we are kind of forced into it by the like JPA and the persistence model that we use, and maybe reading too much on a certain Vlad's blog. And so again, we end up in these situations where, because we have the object model, we have the relational model, and JPA, kind of like an ORM, kind of promises, the best of both worlds, but in reality, it doesn't either result in a good object model, nor the relational model, right? Like, I don't know too many projects where people stick to generating a database based on JPA model. I think it's mostly people just, write their own SQLs and do the migrations themselves on some way. They don't leave it to JPA, or don't leave it to Hibernate. And this is, I think, something that plays into it, is whether we want these two models or not. And again, in some cases, if it's a crude, maybe don't even go with all these layers. Just use the REST repository or something. There are things like that, where you can just expose stuff from the database in your controller, in your API directly, right? Why go through all this bother? The issue is that with many of our applications, they start as CRUDs, and maybe they then get more sophisticated, they have more logic, and maybe then it's kind of hard to reverse that, to go from this like very simplified stuff. There's a lot of work involved, because all this time we've been just, we've been kind of taking this technical debt and not really bothering about paying it back. And then when it's, when it's something like, oh, we need to go to microservices, we need to split this up into parts, it's usually way too late, because, there are other drivers, not just deployments. And with deployments that are driving, are splitting applications into modules, it's way too late to do that. Okay, is it easier or harder to test the different pieces using hexagonal architecture? I think it depends what pieces you want to test, but in my mind, the ideal setup is you have maybe like 3 levels of testing. One is to test the application as a whole through the RESTful APIs, and not to mock or do anything like that with the database. So have something, maybe test containers or something like that, and then like a real database. Do the same for any other external dependencies. So do not mock HTTP clients. Use like wire mock, for example, right? To have like a server, external server, and whole HTTP communication between them, have this, test for everything. But then we probably don't need too many test cases there. We just need to ensure that all this stuff works, and maybe test whether we have correct HTTP response codes back, or have exceptions. Sometimes that's useful. Then on the level lower, it's useful to have unit tests that test the entire module, so not the entire application without all this like infrastructure stuff. Do not mock the database, because it's much more convenient to just fake it with use like an in-memory implementation with like a concurrent hash map or whatever. And then mock any other external dependencies if you need that, and use your services as like points where you can prod the application and see how it works. And at the very lowest level, what you can do is you can have like unit tests on the individual class level, but I would reserve that only to like entities or aggregates, because if your class doesn't really collocate state and logic, it doesn't really make too much sense to test it in isolation. For example, people often test services as units, like single class, but all you do is just verify whether it calls another service or repository or something. This doesn't really make too much sense to me. So I think depending on how involved, how complicated your logic is, I guess I would go from the first one to the last one. So I think if you have a CRUD, it's sufficient to just test it on the API, REST API level. If you have some actual logic in there, it might be useful to introduce this test, especially if you have different endpoints that just call the same functions internally. It's easier to test it once than just repeat those tests over and over for different APIs. And if you actually have interesting Baroque domain model, then is the time to introduce this low-level unit tests that test aggregates and entities. Yeah, I think that's the best way to go for me. So I guess there's no more questions. Thank you.